Thank you, everybody, for joining us tonight. I know you guys are very excited. I'm very excited about this presentation, mechanical and aerospace engineering. We're going to learn a lot of fun things. We have a lot of great people on here, we're going to get started off by Professor Martini. She's going to give a breakdown of the major, how fun it is, and then we're going to have a student's presentation and have a student panel. Yeah, I hope you're excited as I am, and congratulations. And Dr. Martini, let's kick it off.
Thank you so much. Welcome, everyone. Again, my name is Ashley Martini, and I'm the chair of the Department of Mechanical and Aerospace Engineering. And before we get started, I would like our student panelists to introduce themselves as well. So if you four want to join and introduce yourselves, please.
Hi, my name is Roman Perez. I'm from Southern California, like Orange County. I'm majoring in mechanical engineering, just solely, and I've been at UC Merced. This is my first year at UC Merced.
Hi, my name is Sajal Patel. I was actually born and raised on the East Coast in Atlanta, Georgia, but now I live in Merced, California. I'm a mechanical engineering major, but I'm concentrated in aerospace engineering, and I've actually been at UC Merced for about a year now.
My name is Patrick Vasquez. I'm a fourth year mechanical engineering major with a physics minor, and I'm originally from LA, specifically Glendale area.
And my name is Randy. I am from the San Fernando Valley area. I am a current mechanical engineering major, and this is my fifth year currently at the campus.
Really, really quick interruption, Dr. Martini. Just so you know, folks, Sajal is a transfer student, mechanical engineering. So, like I said, for you transfers, we got someone for you. So she'll be able to answer any questions you might have.
All right. Thanks, guys. Thanks for the introductions. I will take over for a little bit now here. So very briefly, I'll introduce the majors. I'm assuming since you have applied and been accepted into either mechanical or aerospace engineering, you kind of know what those majors are, but I did want to just briefly describe them and also differentiate them before I talk about the majors themselves. So mechanical engineering is the oldest and broadest major. There are probably more mechanical engineers than maybe any other type, just because it's such a broad all-encompassing major. Almost any engineering firm probably has a mechanical engineer because we do just about everything. And in fact, that's my training, if you can't already tell. Despite the fact that this major has been around for a long time, a lot of new technologies are coming out and we're learning new things and becoming more and more valuable members of the engineering community. The aerospace major, on the other hand, is a little bit more narrow. It's focused specifically, as the name implies, on aerospace, but this is a rapidly growing field. In fact, the industry itself, the space industry, is projected to be $1 trillion industry by 2030. So this is a rapidly growing field, and there's quite a bit of interest driven by privatization of space travel, as well as a variety of technical advancements in the aerospace field more broadly. So what I'm going to do now is show you, describe what students in each one of those two majors will do. And to do that, I'm going to share my screen. So give me a moment, please. So what I'm showing you here is a flow chart of, I guess, the master plan of the Mechanical and Aerospace Engineering department. Both of these majors are maintained within the same department, but they are distinct majors. Students in either one of these two majors, let me make this laser pointer. Students in either one of these two majors will start by taking the same classes. First, you take your general education, or GE, and also call this major preparation. This includes all your math, your science, physics, chemistry, as well as introduction to computing. Then students in both majors will take engineering fundamentals. These are things like materials, what do you make things out of, statics, how things stay still, and dynamics, how they move, circuit theory, these types of engineering basics that are applicable to both majors. This is roughly broken out by the year, but not quite, not exactly. At this point, you will diverge depending on if you're in mechanical engineering or aerospace engineering. And for each of these, we have core classes. So for mechanical engineering, this might include things like heat transfer, controls, or mechanical component design. On the aerospace side, this would include things like aerodynamics, flight dynamics, and propulsion. Once you take your core mechanical or aerospace engineering classes, Then both majors will take what are called technical electives. And these are classes that you choose. They can be almost anything in upper division, but you have some choices depending on the interests that you've developed, perhaps while taking the core mechanical engineering classes. For the aerospace engineering, you have what are called general technical electives. And these are also open to someone who's getting, I guess, a standard mechanical engineering degree, a mechanical engineering degree without an emphasis. These are just an example here. We have mechatronics, intro to manufacturing, unmanned aerial systems, a whole range of classes that sometimes change from year to year. So the options are quite good. If you're in mechanical engineering, you also have the opportunity to to enroll in 2 emphases. And what these require is that you choose 3 of your technical electives to be specifically for the emphasis in which you are interested. So for example, if you're a mechanical engineer with an aerospace emphasis, then you would take 3 courses from the AE major core engineering list. There's also a new ag tech emphasis in which you take a business class, a novel ag tech class, and an ag machines class. So all of these are considered technical electives. And then the majors come back in again to engineering capstone design. And this is a 1-year-long, 2-semester program where you're put on teams of 4 to 5 students to work on interdisciplinary and real-world engineering challenges. So we partner with industry to identify actual issues that they're having out there in engineering firms and assign teams of students to spend a year solving that challenge. And those can include both AE and ME majors. So those are the classes that you'll be taking, but also here at UC Merced, you'll have a variety of other opportunities to learn and grow both technically and professionally. First of all, as an undergraduate, you may have an opportunity to work directly with faculty like myself on research. So if you don't know what that is, that's what is research. When you take a class, there's a known solution to the problem, and you have to figure out what that known solution is. In research, we're working on problems for which there is no known answer. And here at UC Merced, we have the largest percentage of undergraduates involved in undergraduate research simply because of the smaller size of the campus. The other thing that you would have an opportunity to participate in which I would strongly encourage, are the student clubs. We have a fantastic group of student clubs here. Some of them are philanthropic, some of them are technical, some of them are focused on a specific interest or engagement. But I especially encourage students to be involved in the technical student clubs. Just for example, we have the Society of Automotive Engineers, we have the ASME, which is the American Society of Mechanical Engineers, and so on and so forth. We also have a very strong program in AIAA, which is the American Institute of Aeronautics and Astronautics. And the reason that I wanted to bring that one up specifically is that 2 of our student panelists are from the AIAA team, and I'm going to hand over to them to talk about what goes on in this student club here at UC Merced. So Randy and Patrick, I will give you the microphone.
Perfect. Thank you, Professor Martini. So hello, everyone. Once again, to introduce myself, my name is Patrick Vasquez. To talk a little more about my work on AIAA, I've been in AIAA for about 3 years now, and I currently serve as the project manager for the competition team. And yeah, I'll let Randy introduce himself.
Yeah, and hello again. My name is Randy. I've been with AIAA for about 1.5 years, and I am currently serving as its current aeronautics director, which oversees 3 out of the 6 projects in the club. That means I oversee Project Turbine, UAV, and our competition team, which is DBM.
Okay, perfect. So a little more on AIAA.
Yeah, so AIAA has been around for a really long time. It is actually one of the oldest engineering orgs on campus. As you can see, it was founded in 2014, and it has heavily influenced the engineering sphere as a whole on campus because we like to indulge in projects, be it research focused or competition focused, which we will dive in more later. But pretty much the goal of AIAA as an organization on campus is to give people the hands-on experience that they need in order to feel more prepared as they enter into industry and anything else of the sort. And even if you don't feel like going into industry, we also do provide some research opportunities, such as with Project Turbine and our latest project, which is the Cube satellite, which we are currently working on. If research is ever your thing, we do have something for everyone that is, well, sort of interested in getting any sort of experience in the field. And then here are our project overviews. Again, I stated that I oversee 3 out of the 6, which means DBF Turbine and UAV. I'll give a quick rundown of each, and then if anything, you can always ask questions at the end of the webinar. But DBF is our design, build, fly competition team. As you can see, there's a picture of a plane that we designed and manufactured ourselves at our offsite facility in the Castle Lab. DBF is a year-round competition team, or competition, which we have to do a lot of paperwork at the start in order to fill out and get everything sorted. But once we do get past those preliminaries, we end up designing a plane using SolidWorks, which I don't know if any of you are familiar with that, but SolidWorks is pretty much a modeling program where we would model our plane. And then after that, we would delve deeper into ordering those parts and then manufacturing it, and then splitting up the work from design to electronics to systems integration to all of the sort, just to get the plane to fly and to complete the mission that we were given. Then we have Project Turbine, which is more so a research-based project, which I mentioned earlier. Project Turbine is currently attempting to build a 1:6 scale of the A-10th Warthog, which is honestly one of the more famous aircrafts in any sort of military. And it's also really cool to do this under like a college with the funds that we have and the experience that we have. And Project Turbine is also awesome if you just want to do some design work, because most of it is going to be inside of SolidWorks and any sort of electrics integration as well, because we also just got the turbine engines, which we are attempting to implement into our enclosure that we made a little while ago. And then we'll be test firing that as well. And then UAV, which is unmanned aerial vehicles. We do a lot of research in sort of VTOL propulsion as well as autonomous flight. We also just do a lot of drone stuff in general, such as building drones and programming autonomy in drones to have them fly without us doing anything. We do have to occasionally step in to be a manual pilot because sometimes code doesn't work, and that's okay. That is normal. But so far, UAV has been attempting to build, I believe, a hexacopter drone, which is supposed to have a water payload, which will spray all over the solar farms on campus. If you ever go to the far side of campus near SSB, you can look off into the distance and see the solar farm. That's pretty much what UAV has been working on. And I'll pass it to Patrick to talk more about the Astro side of things in AIAA.
Yeah, thank you. So PDR stands for Propulsion Development and Rocketry. And it's essentially broken down into 2 programs, for which we have the Introductions program, which actually helps you get started into high power rocketry if you're very unfamiliar with it. So the purpose of that is to actually help you build a level 1 rocket that we launch with you up to 2,000 feet. And then from there, we hope to see you guys actually go into the competition team. We're currently competing in the world's largest international competition known as IREC, in which the goal is to reach as close as possible to 10,000 feet, flying a 4.4 pound payload of our choosing. It could be scientific or it could be non-scientific, but we have chosen to go with the scientific route because we have a lot more flexibility in the dimensions that we're allowed to use. So talking really briefly, in terms of the payload that we're launching up, we're actually exploring a vibration dampening structure, for which we're going to measure the properties of that structure and being able to dampen the vibrations caused by the initial acceleration of flight and that impulse that rocket experiences, as well as events such as apogee, where you're going to have an ejection charge separating your rockets into 2 components and deploying your recovery events. So those are all major inducing impulse inducing events. And so yeah, it's one of the concerns that if you were to launch a rocket into space, then you have to worry about what objects are you carrying. And so kind of orienting it towards the competition a little more, we have an air brake system that we're actually currently working on to slow our rocket down to reach as close as possible to the 10,000 mark. So it's going to implement a lot of live altitude control systems. And yeah, so really exciting stuff. In terms of CubeSat, This is one of our NASA-funded projects in which we're going to be launching a satellite up into space, and we're going to be detecting algae blooms in freshwater lakes. And that way we can notify personnel in the area to actually address that problem. So in terms of bringing this back to UC Merced, we have a lot of alumni that work at Boeing, NASA, Blue Origin, and a lot more recently SpaceX. So we often have them coming to campus or joining through Zoom and telling them or telling us about their experience, about how they got into industry, how they're liking it, and what actually made them stand out. In addition to that, we're heavily connected with faculty. So a lot of our members are actually involved in a lot of research labs on campus, or have gotten a research position at other universities through grad school experience or through programs on campus that connect you directly to a professor. In addition to that, we sometimes have industry professionals such as Whisk and Astra coming over to talk about exactly what's going on with their projects. And so, yeah, it's a lot of exciting stuff.
Coolio. And then for, well, outgoing and sort of outreach experiences, we do also sponsor some of our members to go to conferences such as GMIS, which is Great Minds in STEM, and then CHIP, which is, I believe, the Society of Hispanic Engineers, that conference. We do end up sometimes sponsoring the sort of travel fees that it would cost in order to go to those conferences. I believe last year we sponsored, I think, 40 to 50 people. I believe so, around that range. So we got to like finalize the numbers on that. But pretty much what we do is we like to sort of give our members an opportunity to sort of display the skills that they have sort of gained throughout all of our projects. And there's no better opportunity than just go out to conferences where there's going to be recruiters, companies, potential employers, where you can go stand out and sort of make a name for yourself and be known among the industry as someone who is currently sort of developing the skills needed in order to prosper and thrive in industry. I know a few people that have actually gone to conferences such as GMIS, where they ended up actually getting in contact with recruiters from Lockheed Martin and Northrop Grumman, and keeping those contacts as well as trying to keep in touch with them right after they graduate as well. So even after that, they ended up getting some internships, some interviews, and even some people, like right after they graduated, they ended up getting a full-time job offer from going to a conference. So honestly, it is an awesome thing to do, and we're actually really happy and excited that we get to send out people to conferences because it is a great experience. And to have it be sponsored by us, so you wouldn't need to worry about travel or lodging or sort of anything of the sort. All you really need to worry about is looking good and speaking well in front of recruiters, which we also help with as well, because we also host workshops trying to get you to figure out your elevator pitch and your resumes and do a bunch of workshops like that. So we find it a really awesome experience in order to just get involved. So yeah.
And that's it. So if you guys would like to get involved with our organization, this is the QR code to the Discord, where you're going to be able to see a lot of our project updates, in addition to like announcements for when we're going to be meeting on campus. So yeah, thank you.
Great. Thank you guys. So now we'll go have the students, all four of the students go through, and each one can kind of talk about what experience they've had here at UC Merced.
So I'm going to get this started. My name's Roman Perez again. I'm going to be talking about research on campus. So to go back to what Ashley Martino or Professor Martino was saying, yeah, the UC Merced has one of the highest undergraduate research rates. I was able to get into Professor Martini's lab my first semester, just helping out with some side work around the lab. And it's been a great experience. I couldn't imagine doing research at like any other UC just because it's super competitive and there's a much larger population that is looking for research. One of the strongest things about UC Merced is the opportunities. And so for me, one of the biggest opportunities was research. Getting into research, it's kind of something where it can be a hit or miss. For me, I know I want to go into an R&D role. And so research was something on the top of my mind when I was admitted. It was the first thing that came to, and I immediately started sending emails out to these random professors that I had no idea who they were. But besides that, research has been a great opportunity for me, especially. I have been able to work with my grad student Adam on some tribal corrosion experiments. It's been a really great opportunity trying to figure out something that no one has necessarily done before, or at least trying to do it a different way. And so like moving forward, I'm super excited to continue doing research over the next 2 years. And if you guys have any questions about it, I can answer one-on-ones in the chat. So look into research.
Okay, hi. Once again, my name is Sajal. I'm a third year mechanical engineering student. I'm going to talk to you off about like classes you could take potentially at UC Merced. But as a side note, I 100% agree with what Roman was saying. You should do research. 1000% please do research, because I am a research student as well. 100% worth it. So as far as the classes that are offered at UC Merced, there's a wide range of variety. So obviously all of you are in this webinar because you either were accepted for mechanical engineering or aerospace engineering, right? So there is a wide variety of classes offered at UC Merced. And I know like the general consensus is always like, okay, like I'm going to take a math class, or I'm going to take a physics class, or I take all these classes, but how can I applicably apply all of these classes to what I ultimately want to do at with engineering? And I think UC Merced is a really good place for that. So one of the classes that I was just going to touch slightly on is there is an introduction to drones class here at UC Merced that I'm actually currently taking right now. And honestly, like I think it's a really cool class because you get to learn about the inner workings of drones. You also get to fly them as well. So AIAA also works with drones. They do a lot of things with UAVs and they fly them as well. But even if you're somebody that's like, okay, I don't know about their extracurricular activities, this is one of the classes where even if for whatever reason you can't do an extra student activity, you still get the opportunity to do it in class too. It's very hands-on. It's very like, oh my gosh, like, am I going to break something in my lab? Like, if I do it wrong, and like, chances are, like, are you going to literally break it? No. But it's good to have that experience because that's what engineering is about. And a lot of these classes teach you that as well. Like, drones is a very good class because it shows you the inner workings of like, how does a drone work? How do PIDs work? Like, how do these concepts overall apply to the concept of like, you know, aviation and aerospace in general? And I'm pretty sure there's people in here that are like, okay, like that's cool, but like drones aren't really my thing. Like, what am I supposed to do about that? And that's perfectly fine too if it's not, because a lot of the classes that you'll go through, whether it's like aerodynamics, flight mechanics, propulsion basics, stuff like that, those classes will cover maybe certain other niche interests you have. And it's like, even if hypothetically you don't want to do aerospace, right? And you just want to do general mechanical engineering, UC Merced does have a lot of different opportunities to show you how broad mechanical engineering can be, because there's classes that work with like semiconductors, microfabrication, material science, stuff like that. And it's like, those aren't graduate level classes. Those are classes that are available to undergraduates. And I highly recommend taking advantages of those classes because they're genuine opportunities that you may or may not get anywhere else. Like, you hit a lot of core subjects in like your 4-year degree plan with like just general of like, hey, this is what I need to know, right? But you do get those opportunities here as well. So I would personally say, are drones my favorite as of right now? Yes, but I also still have another year and I'm probably going to take a lot more classes because that's how big the opportunity is. And one more thing I did want to say as well, which was touched on earlier in this webinar, I am a transfer student. So I just wanted to emphasize the fact of like, please don't feel like if you're a transfer student and you don't have your full 4 years here, you won't get these opportunities of like, am I going to be able to do research? Am I going to be able to do extracurriculars? Am I going to be able to take all these extra classes because I'm on a shorter degree plan before I graduate with my bachelor's degree versus like a 4 year student? And I just wanted to say like, and encourage that you will. You absolutely 100% will get that opportunity. So yeah, that's it. I think this is a really good program to be in. I think a lot of the opportunities here, the professors here, they genuinely care about their students, and the classes here will genuinely help you and teach you, not just in like a death by PowerPoint kind of way, but you will get a lot of hands-on learning here as well. So yeah, thank you.
Yeah, thank you. I kind of just want to actually add on top of Sajal's points. in that even though you don't have a lot of time here, if you're a transfer student or if you're barely just coming in, there's always opportunity to join extracurriculars. For example, I got a leadership position within AAA within my first or second year. So do not worry about how much time you have left. Worry about what you're currently doing at the moment, and employers will definitely see that. So I'm here to actually talk about our test launch of the IREC rocket that we launched last year at competition. So I can remember it pretty vividly, but I'm going to start kind of like the day prior to launch, where I was at our facility, kind of just stressing out about submitting documents and getting through all the final tests, and making sure that the rocket would actually perform the way we wanted it to at launch. So there was a lot of aspects that were going through my head at the time, but when it was time to leave, it was kind of a blast, not gonna lie, because we left the facility at 12 a.m. From Merced, and I had to drive all the way down to Los Angeles, where I live. And so I got to LA around 4 a.m., needing to wake up at 7 a.m. to go to the Mojave Desert, which is kind of a little past Palmdale, if you guys are familiar with that area. And the launch site that we actually went to is called Friends of Amateur Rocketry, or FAR. As the name also states, Mojave Desert is pretty far away, so a lot of people make jokes about that. But yeah, FAR is a very, very special place, because it actually has very few restrictions. So you actually get to see other universities and their projects, such as other teams competing in the same competition as us, which is IREC, teams competing in Argonia, which is a two-stage competition that we ran in my second year. And you also get to see, most excitingly, hot fire tests, where you see a team's liquid rockets, and then they just flow gases out of it, and a massive stream of fire comes out of the combustion engine. So that was all really exciting to see during my time at FAR. But more talking about my experience with our rocket and our team, it was once we got to the launch site, it was honestly very, very fun. Because there was a lot of things that everyone knew that needed to get done. And once it was time for us to go up to the pad and set up the rockets, it was really nice because they had it very open for us, and you could see the mountains pretty clearly. We had drone shots, so we set up a drone right next to the rocket and had a perfect view of flights. And yeah, I mean, I don't think it could have gone better. It launched actually better than we expected it to. Um, and when it came down to recovering the rockets, it was also interesting because we had to drive through desert terrain, and that was very, very hideous. Just because there was literally everything that you can imagine, tires, glass, everything. So maybe a few cars got damaged in the process, but that's okay. Um, and so, yeah, after the launch, after recovery, we kind of just called it a night. I went to my friend's birthday, and that was the day. So it was really, really fun.
And then I'm going to be talking about my experience as gaining an internship, which, to be honest, in my lifespan of school was kind of a late decision to do, because I found out that I could get an internship quite literally last year, my fourth year, and I'm a fifth year. However, the timing for that was honestly, it's been a good experience. So I am currently an intern for DART, which is a drone infrastructure company located in Monterey Bay. And so basically my work, it was honestly a lot of more remote stuff than I thought I would be doing. But I pretty much worked on designing a gimbal system for a drone in order to have the sort of three-dimensional motion, such as the X, Y, and Z axis as well for potential zoom, on a camera payload that will be attached to a drone. And the entire purpose of that was to fly the drone in sort of in a field over in Chile somewhere. And then after that, after I finished designing the gimbal system and trying to get everything like in tune and in shape with all of the machining and the tolerances and all that other stuff. It was then provided to me that I needed to work on computer vision as well for the drone. Now, that's honestly a lot more coding than I'm pretty sure most of you are going to be indulging in, but computer vision for sort of detecting the specific animals that we want to have just captured in sort of a database, so we can then have a stronger sort of sense of realization for the model that we are implementing into the drone. And it was honestly a really cool experience because I managed to get this internship after a competition that I participated in, which was the Citrus Aviation Prize, which was last year's competition, but they host it every year. So if you're ever interested in trying to do VTOLs and trying to get that sort of ergonomic setup and trying to have everything flow within campuses and other airfields and launch sites, you can go ahead and go for that project as well. I know the DARPA project is also a competition that's happening soon, but that's a lot more with sort of regulations and restrictions than the Citrus Prize. But from the time that I spent over at DART and working on remote stuff, which is honestly, it was cool because I got to sort of imagine how a system is going to work inside of these different steps. Because sure, we could always just skip to instantly throwing a camera onto a drone and then trying to have it fly. But we also needed to make sure that the gimbal was steady and that it worked. So we initially just clamped it to a desk and then just messed around with the gimbal using an Xbox controller. And then once that test was finalized and it passed through safety inspection, then we strapped it onto a little robot car that we made out of spare parts. It was honestly really cool. If you ever want to just make a quick robot car, you could literally just buy stock and go to a quick machine shop on McMaster. And once that passed safety inspection as well, then that's when we start implementing it onto a drone. And kind of, sort of, it was finally an opportunity to implement what I've been learning in my classes into a real world scenario where in any sort of class, when you're working with a problem and you need to come up with a solution, the problem in text, like usually on an exam or a quiz, it's going to be very straightforward and it's going to ask you what exactly you need in order to solve the question correctly. But trying to do that in a real world scenario where you have a general goal of attaching a camera to a drone and that's all you're given. You have no idea the materials, no idea how you're going to connect it electronically, no idea how you're going to integrate it with a computer. So you can see through the camera, through your laptop that is connected to a drone, and you need to do that wirelessly because there's no way you're going to attach a wire to a drone and then fly it up like 400 feet. That is not a good idea. And it really gave me the opportunity to think outside of the box and to apply everything that I've learned in my classes to go through countless hours of designing and coding. And honestly, it was probably the best test of my engineering knowledge that I've gained throughout my years here. And getting an internship was honestly awesome. Getting paid is also awesome too. I'm not going to diss the pay, but I feel like the experience of doing all the work for that for DART was more satisfying than getting a paycheck.
Thank you guys for sharing your experiences. We appreciate it. So we're already starting to answer some of the questions in the chat, but maybe you want to
Yeah, so these
verbalize
questions,
some?
yeah, these questions have been very hot, very interesting. It seems like you guys are very excited. So I guess the first question I would like to ask is, or a student is asking is there a benefit to living on campus and having 24/7 access to the research, or can you do the same thing if you commute?
Yeah, sorry. I would say there is an advantage to being on campus. I feel like my schedule is pretty full, so it might not be like entirely like it, Patrick, if you want to go off this too, like for sure. I live on campus and I take like 22 units right now. So my Monday to Friday is pretty packed. And so being on campus makes it really easy for me to just kind of squeeze in some hours at the lab every now and then. Even if it's like 2 hours on Monday at 8 p.m. and I'm just in the lab from 8 until 10. That's been really helpful. If I lived off campus, I don't think that it would change all that much. Essentially, it's just when you leave. I guess the main difference would be if you had no classes on a Tuesday and you wanted to go into the lab, well, now it's an inconvenience that you have to drive. But besides that, I don't think that there's much benefit to being on campus versus off campus if you plan on being on campus like almost every day.
Awesome. Thank you, Roman. Sujal, what is the best advice you would give for a first year aeronautic engineer? Should academics be the only thing they focus on? I think I asked that question correctly. I apologize if I butchered it.
For a first year, should academics be your focus? Yes. Yes, it should, because obviously you're going to school and like you want to make sure that you can take as many classes as you can handle. But I feel like maybe like you don't have to like jam pack your schedule and be like, let me do like this club and this club and this club and this club. But I feel like along with your academics, if you did one or two, it would be a good thing for you just because it opens you to the community at UC Merced, as well as the fact it might give you more opportunities, especially if you're a first year freshman and you have an idea what you want to do, but not fully. It would give you a little bit more exposure versus just doing classes. So I think, yes, like you don't have to overload yourself, but I think you would benefit greatly even if you just did even one club. It doesn't have to even be anything crazy. Even if you showed up to a couple meetings to any of the student clubs on campus, I feel like you would have a lot to gain.
Yeah, so one of the things that I did want to add is that while academics should be kind of that top priority, one of the biggest priorities is actually learning what you want to do as part of your career. And so the way I actually learned was through joining an extracurricular. So through joining AIAA, I've actually realized that I want to go down the research route and actually apply for graduate schools later down the line, which means that I'm going to need a lot more competitive of a GPA, some research experience to back and show that I actually know what I can do in a lab, and actually display the kind of skills that they're looking for, in addition to the project experience that you can get from extracurriculars such as AIAA. So yeah, I think it very much helps to join that extracurricular just so you know kind of what requirements people are looking for. AIAA is very diverse in how many uh, things or how many career paths people want to take. So we are more than open to also talk with you through that. Yeah.
Awesome, Patrick. Thank you. So this question is for Dr. Martini. Now, since we're a young school, since we're the youngest UC, we're getting questions of how would courses at UC Merced compare to the other UCs in depth and rigor? Um, will there be less content due to the semester system? That's actually a really good question. And what kind of support system is available for students with academics?
Okay, great question. So first of all, the semester versus quarter system. Actually, both we and UC Berkeley are on semester system. I don't think there's any downstep when you go from quarters to semesters. It should be the same. We just distribute the content over semesters as opposed to over quarters. So the content is the same, especially in degrees like mechanical and aerospace engineering. The curriculum is quite set. I mean, one must always take thermodynamics, and it doesn't matter which university you're at, quarters, semesters, whatever. So we offer the same courses as any of the other UCs or any of the other universities for that matter. What really differentiates universities are the types of opportunities that the students have been sharing with you. As I mentioned, we are, in order to prepare students to receive a degree, a bachelor's in an engineering degree, there are set courses, and we are absolutely offering those courses. With respect to support for students, I know there were a few. I don't know if anyone here, any of the students here, have any thoughts on academic support that they've received? If not, I can. You guys are all super wizards.
Like in terms of grants
No, no,
or
no, no. I didn't mean money. I meant like you're not doing so well in a class, need some mentoring or.
I mean, there
uh,
is the Great Student Success Center, which does offer tutoring, especially for like some of the lower division classes. But I honestly encourage the help of any of the TAs that teach these classes. All the TAs are grad students in their own programs, but considering the class sizes are not that big. Typically, most of the classes here, if they're small classes, they're only 30 to 40 students. If they're really large classes, like about like maybe like 100 plus, you typically have like 3 to almost 4 TAs, and you can go to any of them, and honestly, they're all waiting for somebody to show up to their office hours, and they're more than happy to help. They really are. They're very happy when somebody shows up.
So what it sounds like is that they don't even need tutoring services. All the access is just there for them, right? Whether it's the TAs or the professors, they can kind of just reach out and touch them, and it sounds like they're there to support them all the time.
But the
That's
Bright Student Success Center is there too, and that is also a very good academic resource that I will promote actively. It is there. Please use it.
And I'm sorry, Professor Martini, but bug your professors. Ask them for help as much as you can. Yeah.
That's absolutely true. I love when students come to office hours. As Sajal said, it makes me quite happy.
uh next question. This is for Randy, I guess. I'm just picking students now. Does UC Merced have any specialized fabrication labs, or any metal shop or wind tunnels on campus?
Yeah, that's a cool thing actually. I know in our Science and Engineering 2 building, there is a wind tunnel that will be used for your fluid mechanics class. You'll have some labs in there, which is pretty cool. You'll collect data over there. As for machine shops, we do have two machine shops on campus, which is way more than one. We have the manual machine shop, which is in the Science and Engineering building number 1, which focuses more on the manual machining. We have a lathe and a mill that you can actually get trained on. There's a QR code and a website for that machine shop. You can set up any sort of meeting or appointment over there, and then they will gladly train you on how to use the lathe and the mill. You don't need any proper training. You can literally walk in fresh and have that experience. The other machine shop is more so a CNC automation shop that is in the Sustainability Research and Engineering building on the first floor. That is a sort of step up after you finish your manual training in SE1. You can go over there and get CNC training and figure out how to automate machines or the machining process as well over there. But the CNC focuses more so like on just automating small parts, not really getting that sort of fine tuning. That's more so mass production. But we do have both opportunities there. So if you're interested in either or, we do have places where you can go ahead and just go learn how to machine and have the fun stuff.
I want to add one thing to that real quickly. We also have the makerspace. So the makerspace is basically a 3D printing lab. We have just a boatload of 3D printers. Any student can use it with basic safety training. You can send jobs to the printers remotely. You can watch them remotely with cameras that are mounted on the 3D printers. And we actually have a 3D printer checkout. It's like a library. So you can check out 3D printers and bring them home. So we really encourage students, we try to facilitate people taking their ideas and turning them into practice in any possible way. And again, that's called the makerspace.
Awesome. Thank you all. This is a question for me as well. But I saw it in the Q&A. Is there any way that an aerospace engineering degree can help with being a commercial airline pilot or with connections with any airlines, or Air Force, or the military? If not, do you guys have any recommendations?
So at least when you go to conferences, you're oftentimes going to see the US Army. They're looking for recruiting. But I believe they even come to campus um, at least a few times a year. So I believe there's opportunities to also get your name out there just through walking around on campus. Um, but in terms of how much that aerospace degree helps in getting your pilot's license, that's a little questionable, just in the sense that I believe the pilot's license, you just need a certain amount of flight time with a certain vehicle. Say you want to drive commercial planes, that's many, many hours. So that's a little interesting. Yeah.
This is a for me, it's a complex question. So hopefully, one of you, the student panels, can answer this. For the rocketry and propulsion projects, would it be worth pursuing a level 1 high-powered certification before the fall? Is there also a minimum amount of hours required to stay in the related clubs and programs? Wow, that's a doozy.
Okay. So at least if I'm understanding that first part, you're asking if it's okay for an L1 or if you should do an L1 before end of fall. Um,
Yes, yes.
okay. It's frankly doesn't matter. It's honestly a lot harder to do it in fall, just because our local launch sites oftentimes get rained down on in the winter time. So that makes it hard for trailers that carry the motors to actually get to the launch site. So best opportunity would be first or second month of school. So October, November-ish. And then following that, it would be next semester, March, April, May. So those would be the times that we launch. We try to get 2 launches per month. But to answer that second part of the question, how much time you need to spend in AAA just as a whole, there is no set requirement. People spend as long as they want. And as, for instance, if you're looking for a leadership position, you really just need to show that you're motivated, that you're dedicated to the project, and that you want to learn. Those are kind of the three things that we look for. And honestly, it's not as hard as you may think it is. But yeah, I know some students spend maybe 5 hours or maybe 10 hours a week. Some students maybe spend 5 hours a week. I know for myself in leadership, I spend closer to 20 to 25. So it gets up there. Yeah, it very much ranges.
Thank you. This question is for Roman because since he's taking 22 units, on average, how many hours are spent a day studying? And how much free time do you actually have? And are there things to do on the weekend at Merced, at UC Merced?
Okay, I do love this question. I'm glad that I kind of get the spotlight like a little bit. 22 units. So I took 22 units last semester and I took 22 units this semester. I will say, I'm not taking 22 units next semester, by the way. That would be terrible. I don't recommend you guys take 22 units either. Personal, it's just free time. I would say that I do have generally a lot of free time. I don't for my lower divisions, which is why I took as many units as I did. For my lower divisions, I didn't find myself studying that much because I'd taken the courses already. So Physics 8 and Physics 9, I took Physics 8, which is AP Physics C, mechanics, but just the college level of that. So I'd taken 2 years of physics already. And so that was a free class for me. I didn't find myself studying that very much, which allowed me to have that free time. Shifting more so to this semester where I'm taking a little bit more complex classes, with a little bit of them being things that I haven't learned before. I do find myself studying a little bit more. I actually have a midterm tomorrow, so I need to study for that once I get off this webinar. But I would say roughly like 2 hours, maybe, or I would say on average maybe 6 hours a week of just dedicated work. But it's going to be different for everyone. I would not use like what I just said as like kind of like a bar. I would say like most of my friends that I talk to that are taking like 18 units, they find themselves probably studying like at least an hour a day, if not 2 hours a day, excluding like weekends. So I would say 10 hours on a week on average would be about right.
Awesome. Thank you, Roman. For this is can be for Sajal or Randy. Are there jobs for students at UC Merced that pertain to your specific field, like mechanical or aerospace?
Yeah. So the way that I get paid for being like under the field or under the guidance of mechanical engineering is I get a stipend for doing research that is related to my field. Um, you can get paid for research, which is a really cool concept to me. I didn't think that was possible. But I did research and then I woke up one day and my PI said there's a paycheck waiting for me. And I was so happy that morning. but that's at least from my point of view. There are researchers, even faculty, if you could reach out and bother them to figure out if they're doing paid research, you can then delve into the field of any sort of engineering and then be paid through a grant that they apply for, which will then apply to you or to your financial aid, and you'll get paid out from the school in that manner. There's also, I believe, some job listings on our handshake service, which can potentially relate or guide you to some engineering job opportunities. I know some faculty, I believe, at least for, I think last I checked, Ayaswamy from Fluids was doing a sort of open research job posting on Handshake. That was the last time I checked. I have no idea if that's still open or not, but I know some research PIs use Handshake instead of just trying to sort of advertise their research opportunities. And honestly, doing research is how most people get paid under mechanical engineering. As for other jobs, there are on-campus jobs if you're not particularly focused on sort of doing engineering research and getting paid for that. You can honestly work in so many places on campus. So going through Handshake and looking through the job listings as well for that is a lot of opportunities. And there is a way to balance school life and job work. Trust me, it's difficult at first because you have no idea how to manage time because there's only 24 hours in a day. But once you get that schedule going, you can balance school, work, club, leadership. At least that's what I do. So yeah, that's at least my experience with it.
Awesome. So Joe, okay, yeah, you can add. Go ahead. Go ahead.
Well, I was just going to piggyback off of what Randy said, that I also do research as a job. And I was lucky that my PI basically was like, hey, like there is this opportunity. And my PI actually is Dr. Martini. So I was going to say research is a really good opportunity as a job that's engineering related. And Handshake, it does have a lot of different opportunities, especially for on-campus jobs, even if you don't want to dive headfirst into research. But I would say don't let the idea of like doing, because I know research sounds like this big scary term where it's like, because like Randy said it and I'll say it too, like you will have that moment of like, I don't know what I'm doing. I don't know what this is. But like you do end up figuring it out. Like obviously we're all here to learn and it is a really good opportunity. So I would honestly say research is a very good opportunity, and to talk to your professors and talk to anybody and see what opportunities are available to you.
Awesome. Thank you. How was that? Can I ask you real quick? How was the transition from from coming in as a community college to Merced? How was that? How was that? Was it easy? Was it hard? Did the courses transfer real quickly, if you don't mind?
It was different. So I actually did my prerequisites at Merced College. So I had a little bit of an idea of how like UC Merced might work because I did my prerequisites at Merced College before I transferred. I would say the transition was, it's not that it was hard, but it definitely was different because the environment was slightly different. And I guess when I came to UC Merced, I didn't know what to expect because there is this certain, I guess, air of how UC campuses work, especially when you look at like UCLA, UCSD, UC Davis, UC Berkeley, like very big UC campuses where it's like there's a bunch of students, their professors don't have time for them, you barely ever see the TA, you barely ever see your counselor. Like it's just a lot of students always fighting to be the best of the best. That was always the notion I had about UC campuses. So honestly, I was a little worried coming to UC Merced because I didn't know what my experience would be, but UC Merced is like, I guess like what you would call like the baby of like UC campuses, but it does have a lot of opportunities. And I think I was genuinely surprised as a transfer student. It went a lot better. My whole transition period went a lot better than I expected it to be. Yes, obviously it's a UC. Professors are different versus how community college professors operate, especially with their expectations and their demands. But it's not anything unmanageable. It's not anything extremely hard. I just think it's better overall when it's shaping you, especially in like this type of degree course, because ultimately they're shaping you to be an engineer that is innovative and actually puts the effort forward, right? So I think it was a genuinely good experience. I don't think the transition was too hard. And I think honestly, it was what I needed as well as what a lot of other students need and seek genuinely without really knowing like what they're looking for until they find it. I actually genuinely liked transferring here, and it went a lot better than I ever thought it would.
Awesome. Thank you. Okay. So this is the last question because we have 2 minutes left, and this is for everybody, including for you, Professor Martini. What can you do for fun at UC Merced? If each of when you guys, if each of you can answer that, including you, Professor, that would be the last question. We can end this on a light note.
When you guys come to Merced, go to the Central Rock housing, first floor. I founded a billiards club on campus, so if you guys want to play some eight ball, pull up. I'll go easy on you guys. And yeah, that's my one thing for using percent.
Well, aside from AAA, honestly, hanging out with friends, we make banana bread every other Friday. So that's really fun. Other than that, we go downtown, and there's a pool place. I know in the neighboring city, there is a bowling alley. And it's only like maybe 20 minutes away. So it's not too far. And yeah.
Okay, so in my free time, I quite literally live in downtown Merced. There's a lot of places to go in downtown Merced. I could quite literally go, I think, to 3 sit-down restaurants, and the waiters know me by name now, so that's kind of cool. I could just ask for the usual. But besides that, besides the nice sit-down restaurants, there's also arcades around there. I do spend too much money over at arcades playing a lot of the games because I quite literally get lost in time. And then I just keep swiping my card. And then I walk out and I'm down $150 before I know it. So that pretty much is a day of research gone for me, but it was fun. If you're ever interested and want something to do, downtown Merced is probably the best way to go. I know we have Main Street where you can literally just walk up and down it. You're bound to find at least a couple of restaurants and a couple of arcades, just hang out and have some fun. There's also a Cold Stone Creamery on the street of the same. It's awesome ice cream. Who doesn't love ice cream? But that's pretty much what I do.
I like nature, so there's Lake Yosemite, which is right next to campus. If you live on campus, you can literally walk there. It's not that far from the dorms. I like hanging out there. I have a dog, so like I take her on trails all the time, like around here, just around Merced, or like I'll drive out even like a little bit away to just go take her on mini hiking trails and stuff. There's also a lot of farms here, and I may or may not just go and just like say hi to the cows. There's a lot of farms and a lot of cows, and all the cows are very, very cute, and I recommend saying hi to them because they're all very nice. But other than that, I mean, like downtown is really good. There's this cute little pizza place that I genuinely like going to, and they know my face and they know my name because I may go there one too many times. But I mean, like it is like a little small town vibe, but it's cutesy. I think it's cutesy in the good way.
I don't know. I guess how do I answer this in the most professional possible way? I'll just say this. I used to be a professor at a top 10 um, engineering school in this country. And I came to UC Merced for you guys. And I really love the students, and I genuinely like to spend as much of my time as possible with you all. Yeah.
Wow, I think that's a good way to close this webinar. So, thank you very much, students. Once again, congratulations on your acceptance to the Mechanical and Aerospace Engineering program. I'd like to thank the student panel, Randy, Sajal, Roman, and Patrick. You guys are amazing. If you guys have any questions, you can email Professor Martini. She put her email on the chat. I hope to see you guys. We hope to see you guys at Bobcat Day, and you guys have a good night. And thank you so much. This was very awesome. You guys have a good night.
Thanks, everyone.